Okay, in this video I will do this problem. We've got 5 vertices. This is a graph made up of vertices and edges. We've got 5 vertices, and we've got 1, 2, 3, 4, 5, 6 edges. And the first thing I notice about these edges is that they are ordered pairs. That is, they have rounded regular parentheses rather than curly brackets for a set. So this AB really is an edge that points from A to B. Here's one from B to C, etc. And the first thing it says is to draw the picture of the graph. So I'm going to go ahead and do that. And I'm going to draw it like this: A, B, C, D, E. And I'm going to go ahead and draw my directional links now from A to B, from B to C, from C to D, from B to D, from B to E, and from D to C. Wow, okay, so we got them going both ways between B and C, or between D and C's, from C to D and then from D back to C. And it says, what type of graph is this? Well, it's not a simple graph anymore because we have multiple links between two nodes, C and D. And so it's a graph, but it's actually a digraph because of the arrow. So it's a digraph. And does it have loops? No. So it's just a digraph. Okay? Is it connected? Yes. See the figure. Is it a tree? No, because it has a cycle. BD. Now, I guess at this point, once you have directed links, you have to ask yourself, well, can I make a cycle and can I make a path and a walk that doesn't follow the arrows? And so we haven't really gotten into that. Obviously, you can define it either way, so that your walks and your paths and your trails are either forced to follow the arrows or not. Let's ignore the arrows for now. We have a cycle: B, C, D, B. Okay. But technically speaking, if you're forcing yourself to okay, in any case, we can't have any cycles, and so it is not a tree. Okay. Draw a picture of this graph when the node B is removed. How does this change the answers to B, C, and D above? Okay, let's draw the graph with node B removed. I've got A, and way over here I got C, D, and E. And now, do I have, if I remove a node, I have to remove all the links that go to that node, and so I'm only left with these two links between C and D. And now, it's still a digraph, but it's not connected, and it is not a tree because it's not connected. Okay, so that answers those questions. Yeah, that does it. Okay, hope that helps.